Okay, it's a short video this time. We looked last time at the basics of the mole and the basics of something called AR, which stands for relative atomic mass. There's another thing which is similar to relative atomic mass, which is called relative molecular mass, and that has the symbol MR. Now, if we look at what I mean, if we take the atom sulfur, and we take the atom silicon, and we take the atom hydrogen, and we take the atom carbon, each of these substances in the periodic table has two numbers associated with them. So for carbon, there's a 6 and a 12. For hydrogen, there's a 1 and a 1. For silicon, there's a 28 and a 14. And for sulfur, there's a 32 and a 16. Now, these top numbers are the AR. So that one there, that one there, that one there, and that one there. These are all called AR, and that stands for relative atomic mass. What it means is it means how heavy the atoms are relative to each other. So you can see that a carbon atom is 12 times as heavy as a hydrogen atom, because you've got the carbon, 12 there, where's 12, and the hydrogen, you've got the 1 there. It doesn't matter what the numbers mean, they're just relative, there's no units at all on them. What you can see is if you look at the sulfur here, a sulfur atom is 32 times heavier than a hydrogen atom and about 3 times heavier than a carbon atom. A sulfur atom weighs a similar amount to a silicon atom, which has an AR of 28. The AR is therefore the relative atomic mass. It tells you how heavy atoms are relative to each other. The reason they weigh different amounts is because what's inside them, and you get a clue to that is if you look at the smaller number. Now, if you look at this smaller number here, this one here for silicon, which is 14, hydrogen, which is again 1, sulfur, which is 16, and carbon, which is 6. What this is it's the number of protons in the nucleus of each atom. It's called the atomic number, and generally the more protons you've got, the more particles you've got inside the atom, and the more particles you've got inside the atom, the heavier you're going to be. Now, when we're doing calculations, it's only the top number which is important. The bottom number is important when it comes to looking at the position of the atom in the periodic table. Hydrogen, for example, will be the first atom in the periodic table because it's got atomic number 1. Carbon will be the 6th atom in the periodic table because it's got atomic number 6. Okay, now if we look at those 4 numbers, memorise those 4 numbers now, and we'll move on, because all of those substances were atoms. Now, most substances don't exist as atoms. Most substances exist as a mixture of atoms joined together chemically, and those are called compounds. So let's have a look at a few fairly common compounds. We've got hydrogen sulfide here, we've got ethane here, C2H6, and we've got a substance called silane here. Silane is quite similar to methane in its structure, except it has silicon instead of carbon. Now, none of these substances can have ARs because there are a multitude of atoms that have been chemically bonded together. So they have what, instead of called relative atomic mass, they have MR, and that means relative molecular mass. Now, it doesn't matter actually whether they're made of molecules or whether they're made of ions. We call it relative molecular mass irrespective of the bonding in the compound. Let's look at the top one. Number 1, H2S. Number 2, ethane, and number 3, silane. We'll look at the top one, H2S. We've got 2 hydrogen atoms and 1 sulfur atom. Let's go back. We can see that sulfur has an AR of 32 and hydrogen has an AR of 1. So therefore, if we've got 2 hydrogens, 1 plus 1 plus 32, that has an MR equal to 34. The MR of H2S is 34. And the reason is because it's made up of 1 sulfur and 2 hydrogens. Let's go back. Carbon AR is 12, hydrogen AR is 1. Here what we've got is we've got 2 carbons, that's 12 times 2. Let's just get rid of that and use the right pen. That's 12 times 2, so 2 12s, and it's 6 hydrogens, so 1 times 6. 24 plus 6, which is equal to 30. So what it shows you is that a molecule of ethane weighs about the same as a molecule of hydrogen sulfide, slightly less heavy. And the third one, if we look back at silicon, silicon is 28 and hydrogen is 1. So here what we've got is we've got a 28 and we've got 4 1s. 28 plus 4 is equal to 32. And so again, all these substances are fairly similar masses, just simply adding together the ARs of the individual atoms. Finally, when it comes to doing calculations on these, we remember that moles, which of course that very large number of atoms. Moles is equal to mass divided by AR, or, if we're using any of these substances, MR. In this case, AR and MR are absolutely interchangeable. MR is simply used when we have a substance which is made of several atoms bonded together.